We'll officially get started. So welcome everyone. Welcome to our first discovery session of the new school year, I guess, of 2022 fall. Very exciting to be back here. We are joined by Harsh. I will be doing a little intro to him in just a couple minutes. So these sessions are discovery sessions. We like to host them, a couple of them every semester, and they're targeted for students and businesses and other organizations. We hope to give them a better understanding of how to use data and artificial intelligence. Last year, we had some discovery sessions about updating your resume and kind of the best tips for cover letters and interviews and such. So we try to have a variety of different topics that we cover. Before we get into it, I just want to begin by acknowledging that DeepSense works out of Mi'kma'ki, the ancestral and unceded territory of the Mi'kmaq people, and that this territory is covered by the trees of peace and friendship, which is always really important to acknowledge. If I haven't said it, my name is Lucia. I work as a communications specialist for DeepSense and for Shiftkey. And for those of you who don't know what DeepSense is, I'll give you a little introduction. So DeepSense is a project based out of Dalhousie University in Halifax, Nova Scotia. And we work with universities and colleges across Atlantic Canada. We work with companies in the ocean sector who are interested in harnessing the potential of data and creating a smarter ocean economy. So we connect with these companies with the next generation of AI, machine learning, and data experts, aka students like you, who are interested in taking your careers down this path, or maybe learning more about the ocean sector. So we really want to be able to provide those opportunities. So we work with the companies to create a project that best suits the company's needs, and then we'll find a researcher and a student to help execute the project as either maybe a master's research project, a co-op, or an internship. And then we've had past projects in data analytics, data collection, data visualization, and cleaning and processing, and of course in AI and machine learning. And the projects could be anything from creating a deep learning model to track fish, or creating a prediction model for safe navigation in the Halifax harbor, or even a computer model that can identify whale shapes from aerial satellite images. So if you ever want to join DeepSense, make sure and work on some real projects with engage industry experience, make sure you join our student pool. I'll drop a link in the chat in just a moment. But the student pool is kind of our one place we go to fill a position. So as projects, internship, co-ops pop up throughout the year, we will check out our student pool to see if there's anyone in there who can fill the need that the company is working with or looking for, and then we'll pull them in for an interview. So make sure your resume is up to date, and you fill out the questionnaire that goes with it. And this is exactly how Harsh actually ended up working with DeepSense this summer. So I'll drop the link once he starts his presentation. But to get started, so today's presentation is all about setting up a computer vision training model. So computer vision aims to use computer systems to allow for the interpretation of images, and it can be used in countless ways, but it all comes down to the basics of having the images and training the computer to know something about those images and then running the algorithm. So we have Harsh Gawai. He completed his bachelor's in computer engineering in India, and as of August now has his master's in computer science from Dalhousie. He worked at the Indian Space Research Organization in the Space Application Center, where he was exposed to GIS and learned how to work with raster and vector data. And he also has an interest in behavioral analytics, natural language processing, AI, machine learning, and of course, computer vision. So like I mentioned, he applied for the DeepSense student pool earlier this year, and we pulled his application for a computer vision project with a company called Scient Analytics. He has spent the summer working with Scient and is wrapping up soon, or has wrapped up. You're writing a final project, soon. Right? Or a paper? Yeah. So ending it soon. So I'll let him go into details about that. But remember, if you have any questions throughout, just drop them in the chat or in the Q&A box. That's all I have to say. So I'll hand it over to you, Harsh. You can share your screen and we can get started.
I think it's disabled.
Oh, damn. Again. I had to re-able. Okay. Who could share? Good. Now it should be good. There we go.
Okay, can you see my screen?
Yes. Yep, and we see it in presentation mode.
Okay.
Perfect.
Okay. Good afternoon, everyone. My name is Harsh Gai, and today I'll be talking about steps to create a computer vision model on our current project named Identifying Kelp, Algae, and Substrate from Ocean Imagery Dataset. I have started working with DeepSense and Scient on this project, and Scient is a environmental-based company which provides the data analytics for natural resource development and environmental monitoring. So let's get started. So first step to develop any computer vision model is to know your goal. So you have to determine your task, like what task you should be performing, like whether it should be classification or regression problem. So for our task, it is multi-label classification. So what do I mean by multi-label is that we will have an image and that image will have multiple labels on it. For example, kelp, algae, or different species. We have to identify the percentage coverage of each images. So what should be the output of the image? You should know like what your model, what you want from your model to give you the output. So as for our task, we want our model to give the percentage coverage of 8 classes that we have in our data set. So we want the percentage coverage of those classes. Before moving ahead, we'll discuss why use computer vision to process the kelp survey data. So what's the importance of kelp or algae? So kelp provides habitat for commercially imported fish and other marine organisms, and it is a cosmopolitan, which means it can be found everywhere in the world. So why we need to survey them? So kelp habitat fluctuates annually, which means like though they are ephemeral, the kelp bed can be found for one place for 1 year, but for after a few years they won't be found there. So they requires the continuous or consistent monitoring for them. It also has a priority for marine protected areas. So how computer vision enhances our abilities? So monitoring and identifying the kelp or algae species is time consuming, tedious, and requires expertise. So computer vision makes it time efficient, like as we can train the model with the several species with several sample of data, and then we can use the model to automate the process. So after that, the next step would be to augment the data and pre-processing. So as for our data, we have videos of 17 islands, and we have Ariana in our team who manually label the data from the videos, who extracted the images from the video and manually labeled few of the frames from them and make the data set out of it. So why we need the data augmentation? In some of the cases, we might have less samples of images for one class and more samples of images for other class. So we need to make the balancing of it. So to achieve that, we need the data augmentation process. So there are few techniques we can use, such as rotations. We can apply random rotations like 30-degree, 90-degree, or 60-degree, whatever we want. Based on it, we can augment the data. Then we can increase or decrease the brightness level of the data. Then we can perform horizontal or vertical flips on our images. And we can also perform cropping of the image. But for this particular task, the cropping won't work, because if we crop the image, the information will lose some information from the images. But for some other tasks like object detection, or if you want to detect a dog from an image, then you can crop the head of the dog or the body of the dog and can augment based on it. Apart from this, you can use the contrast. You can handle the contrast of the images. For this particular project, we have the video from the islands, and we have the images which were manually labeled from the video, and we extracted the neighboring frames from the video so that we can label those neighboring frames as that of the analyzed images. So that way we have increased the dataset size by 20%. After that, you can scale the images as high dimensional. As for some projects, we might have high dimensional images. So that might not be the efficient way to train the model because it will require high computation power and it will also be time consuming. So it's necessary to scale the images to lower dimension. After that, we have to map the labels with our images. We have to make it sync. Like, you should know what type of images will have what type of labels. So mapping is also an essential part. The next step is splitting our dataset into training and testing part. So why do we visualize our dataset for training and testing? So using that, we can know that how our data is distributed, how our labels are distributed in our dataset, whether they are less, whether some of the labels are less in testing or whether they are more in training set. So by visualizing it, we'll know. So most of the people use 80% of their total data set for training and 20% for the testing. Some of people use 70-30 ratio. For this project, we have 17 videos from the island. So we hold out one video for testing purpose and we perform the model on it. Apart from this, we also applied the Laplacian filter algorithm to remove the blurred images. So because we don't want the noise to train, we don't want the noise to train in our data set. Also, we normalize the data. Why we normalize the data? Because the images, we have to convert the images into an array format. So that array will have a bunch of numbers between 0 to 255. So we have to convert those 0 to 255 values between 0 to 1 so that it will be computationally easy for training the model. The next step is define your model. This is the basic general structure of defining any model. First step is convolution layers, where convolution layers help us to identify and learn the patterns from our images or shapes from the images, such as if you are detecting a TV, then the first step is like the model will detect the lines around the TV, then it will detect the edges, the borders, and then it will detect the shape of the like rectangle or square, whatever it is. The next step is max pooling. Max pooling usually we use to downscale the image so that it will be computationally easy for the model. So by downscaling, we'll extract the most important feature from the images. Following that, we'll have flattened layers. Flattened layers converts the multidimensional input to single dimensional, one-dimensional vectors. And at last, we have output layer, where we'll get the output. Well, we have to mention the number of classes that we want for our output layer to give us output. In output, we can have activation functions in our output layer. For our task we added softmax activation layer, where we get the output for each of the classes, which add up to 1. So we know like this image have 40% kelp, this image have 30% algae in it, and so the loss function helps us to measure how far is an estimated or predicted value, how far from estimated predictive value to the actual value. So for this project, we have performed 2 models, ResNet 18 and MobileNet. ResNet is convolutional neural network which have 18 layers in it, and for MobileNet model, we utilize it as transfer learning method. So what do I mean by transfer learning is the MobileNet is trained on ImageNet dataset which have more than 1,000 classes trained on, and we utilize the capability of that model to detect those more than 1,000 classes to utilize it in our own project. So that way we want to know like how well it performs. Yeah. So next step is to apply callbacks and optimization techniques on it. So if after you define the model, the next step is you have to like monitor it. So how you will monitor it? So first step is you can apply early stopping on it. So early stopping helps us to stop the model when there is like consistent accuracy, or the accuracy is not performing well, like it's not increasing. So after few iterations or epochs, it will stop the model if it's not increasing the accuracy. Reduce LR on plateau means like if the accuracy is not increasing, then we will decrease the learning rate so that it will it will it will go like it will perform well. The third step is like apply model checkpoints. So whenever there is a slight change in accuracy, like in terms of like positive change, or if the model is performing well, then at the same time it will save the model. It will suddenly save the model, and you will have the best model throughout your epochs. For optimization purpose, you can add custom class weights. What do I mean by class weights is when you train your model, the model is initialize the random weights to each of your classes. But if you have data imbalance problem, like you have one class have more samples and other class have less samples, then you have to add custom class weights based on your frequency of those labels in your data set. So we have applied custom class weights to in our data set. So after training our model, we need the evaluation techniques, like what kind of evaluation we should apply on it. The first method is like you can check on your loss function, like how well it performs. Previously, I mentioned that a loss is the measurement of how far your actual data and your predicted value is. So if the red line shows the testing loss and the blue line shows the training loss. If your training loss is too much high, then it means your data is like your model is didn't trained at all. It didn't learn at all. And if your testing data is too much high and your training data is too much low, then it means that your model is overfitting. Your model learn the training data so minutely that it can't generalize your testing set. It can't predict or identify the new objects in your data set. The next step we use for evaluation purpose is absolute error. So what do I mean by absolute error is we have the predicted values and we have the actual values. We took the difference of those. We took the difference and we have plotted it in a histogram manner. So the main idea was to decrease the tail of the graph and increase the head of the graph. If there's if the tail is so thin and the head is if the head is increased, that means that there is very less error in our model and it's performing well. If the tail is increased, like we have too much samples in our tail and very less samples in our head, it means the model is not performing well. So that way also we can know the how well our model is performing. After that, we can evaluate the model using the randomly selecting the manually analyzed images. So what we did here is we have the manually analyzed images and we took the samples from it. We compared the model prediction from the manual interpretation, and we found that like algae 1 has the maximum percent coverage in this image, like around 45. Then comes kelp 2, it's 41%. Then comes other species of kelp 1, which is 11%. As we can see in the model prediction, the model performs similarly, like 40% maximum is algae 1, then it forms kelp 2 31%, and then it's 21% kelp 1. So the model is trying to estimate as accurate as possible to the manual interpretation. For our final evaluation purpose, we created a video. A video in the sense like we have separated out the video for the mole island for testing purpose. So we have processed the frames from, we have processed every frames from that video, and we have passed it to our model to give the prediction. So as the video plays, the on the right side it will have two graphs, like first one is bar chart and second one is a line chart. So the bar chart will have three bars. The blue colored bar will indicate that the average prediction of all the frames from the starting of the video. The orange bar represents the average prediction of analyzed frames that we have manually interpreted, and the green bar represent the average of manually analyzed frame, the actual value of the images. The main idea here is like to make the orange bar and the green bar as similar as possible, so that we know model is performing better. For the line chart, it will update over the time. So as the video plays, it will plot the blue dots. It will plot the blue dots, and the y-axis represents the percentage coverage of each of the images for every classes. And the green dots, as you can see, the green dots represent whenever there is a image or frame comes which is manually interpreted, then it will plot the green dot. And the idea here is to estimate the lines as near as possible to the green dots. So if it's near to the green dot, then we know that yeah, the model is performing better. It tries to read the manual interpretation. So after completion of the video, the frames have processed around 13,241 frames and around 20 manually interpreted images. At last, what lessons that I've learned and what I want you to keep in mind is analyze and map your data properly. What I mean by map your data properly is like in most of the cases, you will have labels in separate file and images in separate folder. So you should know like how to map those labels with your images. Or in other case, you will have the images attached to with your labels attached with your images. So you like attach with your images as in the form of image name or kind of thing. So you should know proper algorithm to properly map your labels with your images. Second lesson I learned is like start with basic models. Don't just jump into the complex models. Start with the basic convolutional neural networks and then gradually increase the complexity of your models. The third thing I learned is like to choosing the best or efficient evaluation technique. So let's say you want to predict the you want to identify the dogs and cats from the images, and you have 100 samples of it. The data set have 90 samples of dogs and 10 samples of cats. So if your model is performing like if your model is detecting all the images as dog, then you will have 90% accuracy. So here accuracy won't work. So you need different kind of evaluation techniques to better evaluate your model. So these are the three things that I learned during this my period with DeepSense and Scient. And yeah, that's all. Thank you so much.
Awesome. Thank you so much for taking the time to share that with us. That was really fascinating. Yeah. Are you a algae and kelp expert now?
Kind of. Yeah. When I started, I didn't have any experience with it, but I kind of tried to learn about kelp and algae. But yeah.
Mm-hmm. Did you find it like, did you have to work closely with the Scient team to be able to identify all the different
Yes,
species?
yes, exactly.
Yeah. And then if anyone has questions, feel free to drop them in the chat or in the Q&A box. But I'm just wondering, this was focused on a certain area, but how transferable would it be to a different location? Would you have to go through and map and annotate the data again with all the different species?
No, it's we have Ariana in our team, so she has the background knowledge about it, and she labeled the images by herself.
Okay.
Yeah.
Got it. And then Jason in the chat is asking, was this a 4-month project?
Yeah, it was a 4-month project, and I extended for 2 months extra.
And did you extend it for 2 months because
Because
you're writing
I
a
was
paper?
focused, yeah, I was writing a thesis, like
Yeah.
I'm focused on my master's thesis also, so yeah.
All right, so we have some more questions coming in. Someone's asking, what are the different ways of acquiring data sets for training and testing?
What are the differences?
The different ways. So how can you, what are different ways you can get data sets for training and testing? So for in this case, all the data was provided to you by Scient from their research, right?
Yeah. Yes. So it depends on the problem statement, or like it depends on the problem statement. Like you can get data sets from Kaggle, or if you are looking for any environmental based projects, then you can get from any environment based sites. But there are plenty of like open source data sets available where you can get. Like I mostly use Kaggle if I didn't find any open source data sets. But yeah, mostly Kaggle is the best way to go.
Great. And then we have Jason asking, are the labels higher? Oh my gosh, I can say this word, hierarchical. This is embarrassing. Like, does one label encompass other labels? So do you have like kelp, and then within kelp, is it like for 3 species, or for another example? You can see it in the chat if that's easier.
Yeah, so we have initially we were have to, like, we have several species of kelp, several species of algae, but the problem here was we didn't have enough samples of the images.
Mhm.
So we converted into super classes like kelp 1, kelp 2, where we have the enough samples. So we made the super class of it, and then we trained the model.
Okay. And then how long did it take to label everything, the data set?
I'm not sure about the labeling part, because labeling part was handled by
Right.
Ariana.
Before,
So
yeah.
before I joined the project. So yeah.
And then you were kind of saying, because you didn't have, would you say you had 17 videos and you used 1 for training? Would you have liked to use more to get more? Or
I used 17 videos for like 16 videos for training and 1 for testing.
Okay.
Yeah,
I see. I misunderstood. Okay, other way.
yeah.
Okay, so so was 16 enough, do you believe, or would you have liked to have a larger set of videos?
Yeah, it was enough, but for some of the labels, we didn't have enough percentage coverage of it. Like, for example, some of the species of kelp, we didn't have enough labels for, like, we didn't have enough images where the actual species is covered. So that was the problem. Like, we need more samples of that to accurately predict.
And so then you had to go find your own kind of images, or that's when you
We
decided
use
to group
the
it
data.
into? Okay.
Yeah, we use data augmentation methods.
Okay.
Yeah.
Jason's asking, when you mentioned model deployment, how are you dealing with model drift?
So what do you mean by model drift?
That's a Jason question. Jason, if you want to elaborate.
Yeah.
He's typing. We could also, if you want to talk, let me know, and I'll give you talking privileges, if that's easier to explain.
You can turn your
Okay,
mic
all
if you want.
right, all right.
Hi, can you hear me?
Yes, we
Yeah, I
can.
can hear you.
Okay, so model drift being over time, your model might not be that great because it loses its accuracy as more data comes in.
Uh-huh.
So how are you? I guess maybe I'm ahead of this, but is your model in production or is
No,
this...
it's not in production.
Okay, then that makes sense.
Yeah, it's not, yeah.
Yeah, then yeah.
It's just, yeah, we use the video to create a video with the model predictions. So it's not in deployment, yeah.
I see. So yeah, because one of the slides says deployment, so I thought it's already in deployment, and then you already have a method to deal with model drift.
Didn't deploy it. It's just we deploy as a video.
Okay.
For promotional purposes, yeah.
It's a great project. Thank you.
Sorry?
It's a great project and great presentation.
Oh, thank you.
And then we have another question, which you might be able to answer, but how is labeling done typically? I know it happened before kind of you came, but did you learn how they did it? So
what they did was they added, for every images, they added pixel grids. Like they added the grids on each of the images, and they calculate the, like, for each image they know like this number of grids have algae in it, this number of grids have kelp in it. So we calculate the number of grids, and based on it we have normalized it according to, like, now based on the number of grids we have calculated the percentage of percent coverage from all over the image. That's how they did.
Okay. And do you know, now that your part of the project is done, do you know what Scient's next steps are, or that you're just not involved anymore?
So the right now the next step is to publish a paper on it.
Okay.
And yeah, that's all.
So we have Amos asking, you mentioned a couple models. Did you experiment with all of them and pick the best model, or did you choose one after mapping the data?
Yes, I experimented with all models and then choose the one. The model which performed best was MobileNet with custom class weights.
Perfect. That's great. They say, cool, thank you. But yeah, I think if no one has any more questions, we can wrap this up. Oh, Jason's saying, aside from the two, did you use ImageNet?
Yeah, I also used ImageNet weights. But yeah, as I compared ImageNet with the custom class weights, custom class weight performed better. It's not like way too better, but yeah, those have similarity in between them. But yeah, for some of the classes, the custom class weights performed well better.
Perfect. Yeah, if no one has any more questions, I think we can wrap it up for today for our first great discovery session back in person. So thank you, Harsh, for taking the time to talk about your project. It was great having you kind of on our team this summer and working on this. I'm just dropping some links in the chat for folks. So earlier I mentioned our student pool. If you missed it, that's the best way. If you want to work with DeepSense, we'll connect you with ocean company that's doing a project, and then you can add your name to the student pool. That's the first place we look when we have projects come up. Also wanted to mention our mentorship program, our STEM connector. It's basically if you're interested in talking with folks in the industry or even other students just like yourselves, definitely check out STEM connector. We've started our fall term now, and we'll have some cool events happening, some networking opportunities, and it's a great way to meet people, grow your own network, and potentially meet maybe future employers or companies you want to work with. And this discovery session is being recorded just like all of our discovery sessions. So we have a playlist on the DeepSense YouTube page where I will probably upload this sometime tomorrow. And then I will share the link with everyone who registered over on Eventbrite. But you can go and look at any of our past discovery sessions. Like I said, there's a good ones about resumes, more about computer vision, some about companies, so check them out. Jason, you're asking about the mentorship program. Is it regionally specific? You're from BC. So technically it is, but it's for Atlantic Canada, but you're welcome to join because it's, for the most part, people are meeting virtually. And it's supposed to be kind of quick one-off conversations. So I encourage you to join. You're just going to meet a lot of people from Atlantic Canada, but that doesn't stop you from networking and growing your networks. And maybe one day you'll come over to Halifax and join and you'll have a great network already. But yeah, anyone is welcome to join. Just follow that link in there, and you just might miss out on our in-person events, but we'll definitely have some online events for STEM Connector. So that brings us to the end. Again, Harsh, thank you so much. It was a great presentation. It was great hearing about your research because I'm kind of involved from behind, and I just kind of hear about things, but it's nice hearing about it from you. So it's great that it went so well for you this summer. And thank you to everyone who joined us today. I hope everyone has a lovely weekend and happy Thanksgiving if you celebrate. There we go. All right.
Thank you everyone for joining. Thank you, Lucia.
Thank you. Bye, everyone.
Bye. Bye. Have a great day.
Thank you.